Hello again, everybody. In this video, what we're going to discuss is one of my favorite uh, methods in JavaScript, which is the map method. It's very powerful. This is just an introductory video, so if you're familiar with how map works and different ways you can use it, you probably won't get a lot out of the video. I'd recommend waiting until I put out something a bit more in depth. But if you're new to map, this is going to be a great opportunity to learn how it works and see how powerful it can really be. So, first things first, we're going to be using 3 different arrays. One is nums, which is just, as you might expect, a list of numbers, 1 through 5, with no numbers skipped. First names, Ron, Leslie, and Bert. Last names, Swanson, Nope, and Macklin. Those will show up later on in this video. So, when you are using map, it is a a method on the array object. So if you have an array, in this case nums, you can call .map on it. You can call .map on it and pass in a callback function that you want to apply to every element in that array. So in this case, we have a list of numbers. So map is going to look at the nums array, which is what we're calling it on. It's going to grab the first value, which is 1, and pass it into our function. So we can see that we've written a function that accepts num, one number, and it returns num, which is the value we passed in, plus 1. Map does not affect the actual array that you run map on. What it does is it treats those values as immutable, and it returns you a new array with the changes applied. So in this case, you will get a return value that I am storing in new nums 1. So down here, if we expose that console log and go node run, then we will see that each value in the nums array has been increased by 1, which is what we would expect. Now you can do this where you write the function directly in the map call. This obviously takes up quite a bit of space, so sometimes you will see people use an arrow function, especially for simple calculations like this, which is just incrementing it by 1. And here I've written out an example, which is x implicitly returning x plus 1. I still stand by that this looks better than what would probably be seen if someone was really going to write it out like this, which would be that. I just think I don't like the x plus plus. I don't think it looks very good. So I would go x plus 1. But realistically, what you'll actually see most of the time is creating a function that you will pass in by name into the map call. So here we've created a function called add2, which is a function that again accepts one number, and then it returns that number plus 2. So if we call .map on the nums array again, we can pass in add2 by name, and that will create a new array, which will be nums increased by 2. And just to show you that the new nums with an arrow function did the same thing, I'll uncomment both of those and see the nums arrow function increased it by 1, and then nums.map with add2 passed in increased it by 2, just as you would expect. So you can also call .map directly on the array itself instead of storing it in a named variable and calling map on that name. This I think looks kind of weird, but you might see that. So this is just a heads up that this is something you could see, and it'll behave exactly the same way. When you pass in a callback function, it'll just execute each value, that function on each value in the array, and return you a transformed array. Here I have an example of how you can perform things that mix types. So in this example, I am returning a template string with num interpolated twice. We have your old number was num, so just using the num value directly in the template string. And then your new number is, and I've called add2 with num passed in, and that logic will actually be performed at runtime inside of this template string and give us a new sentence. So if I unconsole log that, then we get a sentence for every item in the array. So when we add 2 to 1, our new number is 3. When we add, your old number was 2, and then you get 4, and so on and so on. So what map is doing here is it is doing something to every item in the array and then returning you that new array. And it makes sense, I think, to start with numbers as a base for understanding how map works, but numbers purely aren't the most interesting. So let's move on to strings and objects. So here I've created a function called makeUpper. It takes a string and simply calls string.toUppercase on it. So it'll map over our list of first names. We'll pass in makeUpper, and it'll make every item in that array uppercase. So let's call that, and there you go. We've got Ron, Leslie, Bert, and they're all uppercased. Next up, we've got an example of how you can create an object. So you can pass in a string, and we could make this string a key, but in this case, I've made it a value. So we've created a new object, and then we're going to return that object. But first, we're going to create a first name property with the value of the string that we pass in. And you can do as many properties as you want, just as you could on any object. So in this case, as an example, I've added a property called home with a value of Pawnee. I'm going to have to uncomment that if I want to be able to see it. And so in this example, what we are doing is we're calling .map on first names, passing in make object, and that will take each of those first names and return an array of people. And if we look at that array of people, I forgot to save. If we return that array of people, like so, then you've got an array where you've got your first name, Ron, home. Oh, apparently I've already applied something else down here, which is adding a job. So what am I looking at here? People, chained results. Oh, okay, so next example is a chained result. So this is just an example of how you can take first names, apply a map to it, in this case make upper, just like we did up here, but then you can immediately chain another value or another transformation onto that, which is make object. So I'll get rid of this. Apparently I had done some sort of mistake with my naming, and I've ended up applying another transformation onto this without really noticing. So we'll go back to that in a second when we get there. If I run chained result, now you can see that first we're taking every name and we are making it all uppercase, and then we are creating it, we're making it into an object. So we're doing this transformation, and then we're mapping over that transformed array and returning an array of objects with that transformation still applied. So that's pretty cool. You probably won't see this a ton with the way that ES 2015 has given us a lot more freedom with composing functions together. But at the same time, this is a handy tool to know about, and especially doing map and map. I guess that's probably more common than anything new with ES 2015. You'll probably see something like map and then maybe reduce or map.filter, but you can chain maps together if you really wanted to. So this is where I ended up accidentally mixing my two examples. This is a object transformation. So up here, we took a string and created an object, and down here, we're taking an object and adding a property to it. So we're going to take in a people object, and we will add the property government something or other, the value government something or other to the job property. And I actually see what I'm doing wrong here. Let's new object, and we will return new objects. So what I was doing there was, that was a mistake, was I was not treating object as an immutable value. I was actually doing this in place. So what I would need to do is create something, a empty object like that, an object like that. So I'm creating a copy of the object and then doing that. I think that'll work. This will be new object, job. Let's see, I'm doing this on the fly, and that's never a good idea. But let's see if this breaks my code or not. No, it still did the same thing. So I'm clearly not thinking about something quite right here, but the goal is to always treat your values as immutable. I've clearly made that mistake. JavaScript lets you do that, which is not ideal. Ideally, we would want to make sure that we have this object being passed in and not changing the value of that object. We would instead want to create a property on a new object and return that new object. So let's say for now that this is an example of what could be done, but it's actually doing it incorrectly. So we'll remove that because it's a bit of a mistake, and somehow I missed it in all my pre-show testing. Next up, there's an example of how you could make full names. So we have two arrays up at the top here. We have first names and we have last names. Maybe we want to join those together. Well, map actually has an index property, or an index argument that is passed in. And that's the index of whatever item is currently being transformed in the array that you call .map on. So in this case, we're calling .map on first names and passing in make full names. So it is going to pass that string of whatever name is being transformed into the first name argument, and then it's also going to pass in the index of that name. And since these are in the same order, they're essentially pairs, then we can simply take the last names array and the index that was passed in, and we will get proper paired up results of the first name and the last name, and we can return that person object with a first name and a last name property. Hit the wrong button. There we go. Save that. Map object.transform. Oh, this must be needed or something. Let me see here. Oh, that would be because make full names. Wait, what error was I getting there? Let new jobs equal. All right, let's, oh, yep, because I commented that out. There we go. And so there's our person array with our first name and our last name, and we can see that they match up properly because the indexes of these two arrays were paired properly. So Bert was in the same array position in the first name array as Macklin was in the last name array. And so it creates those pairs. Let's comment this guy out. If I could hit the right buttons, that would be nice. And of course, if you can map over everything else, you can also map over lists of functions. So here I have what is essentially an add1 function. I have an add2 function, and that make num sentence function from above, which is this guy here. And what we can do is we can create a transform function that is going to accept a function and call that function with a value passed in and return the new function that results. So we have our first function in the array is going to accept a number, and then it's going to increment that number by 1. So if we call that item in the array with transform function, then that function is going to be passed into our transform function, and it will be called with 42. So the result of that transformation will be that transformed functions will have a 0 indexed value of 42 or of 43. Likewise, this first index will be 44, and then it'll be a sentence that explains how you went from 42 to 44. So let's see how that works here. Man, I keep hitting Command W instead of Command S to save. And so we get 43, 44. Your old number was 42. Your new number is 44. So what we've done there is we've mapped over a list of functions and called every function by passing in the same value, which is pretty cool. I'm not sure when you would necessarily do that. I guess maybe if you're making a bunch of, I don't know, AJAX calls, something like that, you might end up in a situation like this. And finally, if you're creating a function that needs to be, that returns another function, in other words, it uses closure, we could actually map over this outer function and pass in a value to be stored, and then we'll have an array of functions with a stored number value in it, and then the example function I've provided inside here would then accept an object and add that number as an age property to that object and then return the object. So this one won't be very exciting because it'll just say function, 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 but you can see that if we take the nums array and we map over it and pass in the closure function, it's going to call this outer function passing a number every time, and this function will be returned. So we will end up with a list of functions stored in the closed functions array. I go here, function, 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 and if we wanted, for example, I think we could do something like this, toString. And this, I think, will show us. Yeah, so there's our list of functions. You'll see each one takes an object and it adds the number that we passed in before as a age property on that object that we're going to pass in next time. So that's how you can transform functions, transform objects, and transform strings, transform numbers, pretty much everything that every data type that you can work in JavaScript. As long as it's in a list, you can map over it and do some transformation to it. And remember, that's the big distinction with map. You want to use it to do things to a list. For each, it often gets confused with map, and that's when you want to do something with the list of items in that array. So again, I made some sort of mistake here that I'm going to have to look at. Maybe I'll include an update on what I did wrong here in my next video on .map, because that's a shame. I'm annoyed that this happened, but I think it's a good example of how map can be used to create side effects, even though it's built in a way that suggests that you shouldn't do that. So have fun with map. I hope you learned something if you're new to map. And if you did, keep an eye out for the next video. I'm going to try to do some more videos on reduce, filter, and some of the other functional programming-based methods that JavaScript provides, because I think they're super powerful and pretty fun to use. So have a good one, and I'll see you in the next video. Thanks, guys. Bye.